So the parameters of the function f of x equals a sine of b multiplied by x minus c plus d are a, b, c, and d, and the table below shows the possible values for these parameters. Okay, so the question is, using only the values for each parameter from the table, the number of possible equations is. Now we're going to stop right there. Each of those parameters has got two options, and there are four parameters, and so that's going to be 2 to the 4 for options, or 16. Now, the next question is different. The number of unique graphs is what? Okay, so what we got to do is take a quick look at this, at the setup here, and identify the graphs that are going to look the same and what it is that's connecting them. And here's what we can tell here. If I give you, for example, if we start with y equals, and let's just say that we start, sorry, I have a couple over here. Let's say sine of 2 x minus pi over 2. We'll go plus 3. Okay, we start like this. Now, if I just multiply through the argument, I'm going to get 2x minus pi plus 3. Now, consider this, though. What if I have negative sine of 2x minus pi plus 3, and I multiply that through, so negative sine of 2x minus 2 pi plus 3. Now, remember how sine works. Okay, it's going to go up like this. This right here, its period is 2 pi, half of a period is pi. So, oh, sorry, and I didn't mean to have one, those weren't both supposed to be negative. Sorry, the second one here, I need that to be positive. Sorry, no, I'm sorry, I took a quick look back and completely misread my own work here. So the first function there is positive, the second one is negative here. And notice that the shift between them is a half period, okay? I was hoping that you could kind of see it more clearly here and here. Granted, there's been a stretch, a horizontal stretch, but the difference between those periods when you multiply them out, or even if you just look at them from the original there to there, there's a half period difference, and then we introduce a reflection. So we shift it over a half period and then reflect it. Well, that's going to look exactly the same. Okay? So I can do that. Okay? I can do that with these two functions right here. So there's some doubling up there. If I switch the signs, okay, and move this thing around a little bit, if I can switch the signs on like which one's positive, which one's the negative, I'm going to get two more functions that are just canceling each other out there. They're the same thing. Then I can take these plus 3's and replace them all with the negative 3's. And then I just move that whole graph down. And then I do the same thing. I shift it over a half period and then reflect it vertically so that it just overlaps itself perfectly. So I'm actually going to lose 4 different functions here by doing that, which means that there's actually only 12 unique graphs that we're going to see from this question.